So, morning to everyone. Today we will take a look onto the evolution of voltage regulators, which can be found on various types of aircraft. So, what is the purpose of the voltage regulator? The purpose of the voltage regulator is to keep generator output voltage constant, irrespectively on what load is connected and irrespectively on how fast generator is rotating. How do we can do this? We can adjust the field current which flows through the shunt wound of the generator. So the question is, how do we can adjust the field current of the generator? This can be done by many types of voltage regulators. Of course, it is done fully automatically. So the first type of the voltage regulator, most probably it was a vibrating contact regulator. Unfortunately, I do not have it here, because it's really old. And the next type of the voltage regulator, it was a carbon pile voltage regulator. So carbon pile voltage regulator has two parts. It consists of stack of carbon washers and the voltage coil. Stack of carbon washers, so-called carbon pile, is connected in series with field current. So in series with field winding. So the field current flows through the stack of carbon washers. These carbon washers are compressed by means of this spring plate. When these are compressed tightly, their resistance reduces and the field current will increase, and therefore output voltage of a generator will increase. If we will remove compression force, then resistance of the carbon pile will reduce, and therefore field current will reduce, and therefore output voltage of a generator will reduce. Unfortunately, this should be done automatically. Therefore, carbon pile voltage regulator also has voltage coil. Voltage coil is connected between output positive lead, this is the plus, and the airplane skin, this is the minus. So the voltage coil sends output voltage of a generator. Voltage coil acts like an electromagnet. When voltage of the generator is high, then this voltage coil produces very high attractive force. So it starts to attract this armature, and therefore compression force will reduce. So high voltage, more attractive force, compression force reduces, therefore resistance of the carbon pile increases, therefore field current will reduce, and therefore output voltage will reduce, and vice versa. If we, for example, increase the load, then output voltage will slightly drop, then voltage applied to the voltage coil will drop too, then attractive force will reduce, then compression becomes more powerful, therefore resistance will reduce and the field current will increase. So the output voltage of a generator will increase. Here is the cutaway view of a carbon pile regulator. So it has a voltage coil. It is wound like this. These are cutted windings of the voltage coil. And this is the carbon pile. A lot of carbon discs, carbon washers compressed together. Compressed together. Compression is done by means of this spring plate. This is the spring plate. So spring plate compresses carbon washers. From other side, we have this electromagnet called voltage coil, which attract the spring plate. Here is the small air gap. Of course, it can be adjusted. So it can attract the armature. So Carbon pile is connected in series with field winding, and therefore field current flows through the carbon pile. Since it produces variable resistance, which can be controlled by means of the force from the voltage coil, this variable resistance, this is the resistance, as well as current in power of 2 times resistance, this is the power. So it starts to heat. Yeah. So this pile starts to heat, and therefore we need this cooling to remove heating from the carbon pile. Under rated loads it heats a lot. Yeah. So the heatsink is not so small. Yeah. Compared to my hand, it's not so little. Yeah. Also, voltage coil heats, so it also has its own heatsink. Also, we can adjust output voltage by means of changing compression, which is applied onto the stack of carbon discs. So this voltage regulator is adjustable. So actually it was really extensively used on many aircrafts. So why it is not used for today? It has 2 problems. Problem number 1, it heats. Heating, these are losses, yeah, so we lost some power. And the second problem is that these carbon washers, due to vibration of the aircraft, yeah, these carbon washers start to wear out. Therefore, after some time, we have to make adjustments, yeah, adjustments of the compression. In order to reduce vibration impact onto the carbon pile, carbon voltage regulators are placed on vibration dampers. Yeah. So when airplane vibrate, yeah, extensively, then a voltage regulator remains almost unaffected. Here is the complete, this one. Yeah. So it also has these shock absorbers. Here's another type of the carbon pile voltage regulator. It also is fastened by means of springs. Yeah. So it also can shake. Yeah. So the vibration is removed from the sensitive elements. Yeah. Also, we can adjust its compression. We have to remove this lock wire, and then we have to rotate this compression screw. So 2 problems: heating and mechanical wear of the carbon pile. And the mechanical wear of the carbon pile make this type of regulator unreliable. That's why, further, we had moving to the fully solid state regulators. So this is the transistored voltage regulator. Yeah, it has large transistors. These are there inside. I don't know, do you able to see them or not? Yeah, large transistors inside. Transistors also produce heat, yeah, heating. So we again have these heat sinks. Yeah. So the problem with heating is not removed from here, yeah, it still is here. But the problem with mechanical wear, which was here, is removed because transistors does not wear out. Yeah. So these extensively increase life of the voltage regulator based on transistors, and such a voltage regulator is called solid state voltage regulator. Especially this voltage regulator has possibility to control its output voltage, so you have to remove this cover. Yeah. Here is the nut. Nut should be released, and further, by means of screwdriver, on working airplane, on working generator, yeah, you can adjust the output voltage, increasing and reducing. Finally, for example, you will set it to 28 volts. Then by means of wrench, you will fasten this regulator, and then you have to put back this cover. So during line maintenance, older voltage regulators allows regulation of the voltage. The next step was to combine together all functions. So we have to combine voltage regulator together with generator protection. Yeah. So this guy provides only voltage regulation. It is transistored and it provides only voltage regulation. On more complicated system, more modern, voltage regulation is provided by means of this line replaceable unit. Yeah. So I can remove it. Yeah. I can remove it. This is the line replaceable unit. I can remove it during line maintenance. Yeah. And further, I can put back some new one, for example. Yeah. The second unit is used to make protection of the generator. What kinds of protection do we have? Over and under voltage will cause generator to switch off. Over and under frequency, which differs from 400 Hz, will cause generators to switch off. And of course overload. If extensive load current exists, then generator will be switched off. So these two units, yeah, these two line replaceable units are for the one generator. These are for another generator. If this generator should to operate in parallel, then we have additional unit which provides paralleling of AC generators. Yeah. So load equalizing as well as phase synchronizing for all four generators, because such airplanes typically like Boeing 747 has 4 generators. The more modern approach is to put all these 3 units related to one generator, yeah? All these 3 units, voltage regulator, protection and synchronizing, to put all these 3 units into one case, into one unit. And this unit is called generator control unit, or GCU. As you can see, this is just a black box, yeah? It has no any regulators like we had here and also here. Yeah, we can remove also this cover and we can adjust the output voltage. Now it is impossible. Yeah, this is just a black box. Here is only one control. This is the not a control actually, and this is the circuit breaker. If something occurs and the current becomes very high, then it will trip, and we will see this white mark, yeah, white band. It means that the circuit breaker is opened. In order to reset it, I have to press it back. 5 means 5 ampere rated. So if current is more than 5 amperes, it will trip automatically. Also, I can trip it manually in order to disable GCU. GCU, in a similar way like these units, is placed into the electronic shelf. Yeah. But I do not have this electronic shelf. So let's take a look what we have inside. Here is a lot of screws. These are already removed, and I will also remove the last one. As you can see, it is covered by the mark, yeah, so we can't open it during line maintenance. Yeah, so this is the line replaceable unit. We have to replace it during line maintenance if something occurs. We can't open it. We can open it only in specialized workshops, or we can open it here. Yeah. So here's the cover. So it's fully solid state. Yeah. I will open also this PCB. We'll remove it. So as you can see, it's fully solid state. Here we have no any moving parts, only transistors, yeah. Capacitors, relays. No, relays has moving parts, yeah, contacts, but no other moving parts are here. Transformers, ICs, and so on. On the back of the cover, we can see hint of the adjustments, yeah. So, over frequency level, under frequency level, over voltage and under voltage level, output voltage level, and overload level. If we will take a look here, okay, if we will take a look here, then two regulators. No, I have to take a look like this, yeah. Maximum power resistor, yeah. Adjustment, output voltage, yeah. Further, under over voltage, and so on. So, when this PCB is installed, yeah, we can make adjustments from here by means of screwdriver, yeah, by rotating these resistors. This has a lot of turns, yeah, so they adjust very smoothly. But as you can see, it's not possible until I will not remove this cover. But I can remove this cover only when this screw is removed. And this screw is under this seal, yeah. It means that we can't make any adjustments during line maintenance. Any adjustment can be done only in approved workshop, yeah. That's how the modern GCU differs from the previous models, where some adjustments can be made exactly onto the airplane, yeah. So now I will quickly demonstrate you how do voltage regulator operates. Actually, on this test bench I have this very tiny carbon pile voltage regulator, yeah, but it will be fully enough for us. Also, I have these measurement equipment, field current ampermeter, load current ampermeter, and the output voltage voltmeter. Only three. This one is not working. Is not connected. Yeah. Also, I can adjust field current manually if the voltage regulator is kept off, and I can adjust the load. Here is the DC generator. Yeah. 350 watts only, very tiny. Yeah. And here is the speed from 3,800 up to 5,900 RPMs. Yeah, so very tiny generator, but it will be fully enough for our testing. Yeah. And here is the drive for the generator. This is the induction motor. And also I can adjust the speed of the induction motor by means of changing applied frequency to the induction motor. So okay. I will connect the field, and now I will start the rotation. Look onto the indication. So this is the self-excited generator. So it already starts to provide field current, yeah, through this rheostat, and we got some output voltage, which is more than 30 volts. So what will happen if I will apply some load? I applied load and the voltage starts to drop. If I will apply higher load, look onto the load current. The output voltage reduces. So less load, higher voltage. More load, lower voltage. Yeah. In a similar way, speed has impact onto the output voltage. I will remove load, no load, output voltage. Lower speed, and we got less voltage, higher speed and we got more voltage. Yeah? So this is the problem. We have to somehow adjust the field current in order to keep this voltage exactly at 28 volts. This can be done automatically by means of voltage regulator. In my case, I have the carbon coil voltage regulator, so I will switch it on. So now, field current is adjusted automatically in order to get 28 volts. Look, I will apply a load and voltage doesn't change. So I am applying higher load and voltage doesn't change. Yeah? So look onto the field current. When I apply load, output voltage starts to drop. It is sensed by the voltage regulator, so it starts to increase field current. I am applying load and the field current starts to increase. Yeah? I am applying load and the field current starts to increase. I am applying load and the field current starts to increase in order to keep output voltage constant at 28 volts approximately. Yeah? In a similar way, the voltage regulator will adjust the field current if I will change the speed. Look, less speed, more field, in order to keep 28 volts. More speed, less field, in order to keep 28 volts. And of course, if I will switch it off, it will stop. And now it is not able to keep the field, so it goes to 0. Let's check how it looks when I switch on the drive. The self-excitement will take less than 1 second. Yeah? And now it is really working. We have around 28 volts. Yeah. So that's how all this stuff is working with respect to the voltage regulation. So, thank you.